Good day, I'm Dr. T, and welcome to my messy living room and the game Banished. So Banished is a game where you start out with about 10 medieval peasants set in medieval Europe. You've been banished to wherever you happen to be. Let's see what my time scale is. Okay, good. And yeah, you have to survive, build a community, prosper, and thrive. And with this game, the vanilla version is definitely hardcore. It's not horrible. It's not Dark Souls by any means. But, it's, something that it's a little harder than I really want to go for. I'm going for a little bit more of a chillax. And so I've got some mods. And I actually want to jump into one of those mods. And that mod involves this building. This is the charcoal pit. This is not part of the vanilla game. Instead, the vanilla game has the mine. It's got the question mark because I don't have any miners at the moment. So to do this, I really want to point out the key part, and that is your blacksmith. And the blacksmith is part of your supply chain. For your citizens to do anything, they need tools. And tools come in two varieties, iron tools and steel tools. And so the idea here is you've got iron, which in the game is a resource just kind of lying around. Let me see if I can find some. That's stone. Ah, there's some iron. Okay, that's way too far away from me again. So you've got some iron. So you gather that, you get some logs, and your blacksmith can make iron tools. And your citizens absolutely must have a tool to work, otherwise they don't do their job. And thus, if you run out of tools, you lose. Everyone dies. Now, with this game, there's this kind of motif of upgrades, better efficiency. So you can get steel tools, which last longer, and therefore you end up using less iron overall. And I don't know if they gave you any other boosts, but it's definitely good to have. Now, steel tools are going to take logs, iron, and coal in the vanilla version. And coal you get from a mine like this. But mines really are an absolute pain to deal with. Your people will die quite often working in mines. Which is very realistic. Mining in Middle Ages, even today, mining is a hazardous thing to do. A lot of people die in mining. Definitely more so than now, but it's definitely, one of the more hazardous occupations. And so the idea here is that steel is going to be iron with a small amount of carbon in it. But this is where the game deviates a bit from real life. And man, I would not want this to be too realistic because it would be a pain. This would make this hardcore game far more hardcore. So in reality, when you go over, you don't have iron just lying... Oh, wrong button. One of my complaints in this game is Q and E are turn, where I am not used to that. I'm used to those being strafe. So you don't just have these iron... I think that's iron. You don't just have iron metal lying around, which, presumably that's not. It's iron ore. But you don't use iron ore. Blacksmith, who got some iron ore, could not use that. Instead, you're going to have to first smelt it, put it through a bloomery. So the way a bloomery is going to work is you take your iron ore, and iron ore is going to be an iron salt. So it's going to be iron 3 typically, or iron 2 and iron 3. So it could be like magnetite. And it's going to have some other things on, some oxygen, some sulfur, some other anions to go with it. And it's going to be mixed in with silicates and other minerals. And so what you need to do is you need to add electrons to that iron. You need to do what's called reduction. And it's called reduction because of smelting. In smelting, you take, a ton of iron ore, and you do not get a ton of iron out of it. You get a fraction of that, unless you reduce it down. It's kind of like cooking. You take your soup and you reduce the volume by boiling off some of the water. It's not doing that, but it's kind of the idea. So in kind of what medieval Europe would be using, this is not how we do it now, at least not exactly how we do it now. You take a bunch of iron and a bunch of charcoal, because actually this mod makes this more historically accurate. Because most of Europe would be predominantly using charcoal for their fuel source, not coal. Although coal was definitely a thing. Coal tends to burn dirtier, and you get coal smoke. It's not pleasant. So there's preferences for charcoal, and charcoal you just get by, well, I'll get into that. You get that from wood. So for most of Europe, charcoal was your preferred fuel source. So you take your charcoal and your iron ore, you pound your iron ore, you grind it up fine, and you mix that with charcoal, And then you want to heat it in a low oxygen environment, because what you want to do is have incomplete combustion. And this whole narrative is going to be about incomplete combustion. So complete combustion, you're going to take your fuel source, which is going to be, in this case, a carbon, maybe hydrogen and oxygen in there. So if you got wood, that's going to be cellulose and lignin. That's going to be carbon, hydrogen, oxygen predominantly. You might have some nitrogen or other stuff hanging out there too. But predominantly carbon, hydrogen, oxygen. And then you're going to heat that up, react that with oxygen, and form CO2 and water. Now, that's complete combustion. If you don't have enough oxygen, what ends up happening is the heat breaks the bonds in your fuel source. So your wood or your coal or your charcoal. And as it breaks the bonds, then those react with oxygen that also helps break the bonds with. But if you don't have enough oxygen, then you start forming carbon monoxide, not carbon dioxide. That's why if you've got a gas stove or whatever, then what you want to do is have a CO detector in case things go wrong with your gas stove or your gas fireplace, your gas heater or whatever, and it accidentally has an incomplete combustion. You know about it before carbon monoxide kills you. Now, in smelting, you want carbon monoxide. So you take this charcoal and iron ore mixture, you mound up some dirt around it to limit the oxygen, and you set it on fire. You control the oxygen. You want to control this very careful because you want to get a good high heat in there, as hot as you can get it, but you want a lot of carbon monoxide too. And so then the carbon monoxide will react with the iron in the iron ore, and it will donate electrons to it, what as chemists we now call reduction. So originally came from this whole iron production. Now as chemists we call donating electrons. So something getting more electrons, we call that reduction. The opposite's oxidation. So if something loses electrons, it's oxidation. And since in order for one to gain, the other must lose, there's always both. So carbon monoxide is being oxidized, turning into carbon dioxide, hopefully. And then the iron is being reduced. Thus, together, we call this a redox reaction. So, yeah, you've got that. Now, this is what we would call a bloomery. And it's not able to get high enough heats to melt the iron. So you'll get high enough that a lot of the silicates will melt out, pool at the bottom. That's called slag, but not all of them. And you'll be left with kind of these spongy iron globs. Now, if you can get higher heats, what we call crucible steel can be made. And in this case, you get high enough to actually melt the iron. In the Middle Ages, this is not something you see everywhere. Parts of the Middle East, I think Sri Lanka as well, could do this. And basically what you need is some pretty hardcore forced air and a very carefully designed oven to do this in. Because you got to get it super hot, right at the limits of what charcoal can get you. So yeah, now you've got that. That would be shipped over to the blacksmith, where they're going to heat it up with charcoal because you want that high heat. You're going to pound that and start folding it over because you couldn't melt it. There's still slag in it, so you're folding it over and over again, and that is going to expose the silicates, and those are going to come off in the sparks. So if you see all the sparks, that's from an impure steel being purified. Now, during that bloomery process, you've added a lot of carbon. Not all that carbon just fluffed away. It stayed in there. It's going to incorporate itself in the crystalline structure of the iron, and usually you want that. Pure iron is basically non-existent. You can make it, you can get it, but it's very, very rare because it's very costly to make, and it's not particularly that useful. You want some carbon in there. It's going to toughen up the crystal structure. Just checking on my fields to see if everything's going right. And as such, then it's going to make a better metal. So usually what we call iron actually has a lot of carbon in it. So it's really what we would think of as steel. Steel, in common usage and kind of even in technical usage, has carbon inside of its crystalline structure, interacting with those iron atoms, but it doesn't have very much. It only has a couple of percentage, or a couple of percent carbon in there, enough to really toughen it up, make it a better metal, but not so much that it makes it very brittle or problematic. So the blacksmith is going to be beating it around, and that will be controlling it. So in reality, all of this involved would require charcoal and or coal. The reason you can't just use wood is it doesn't get hot enough. So the way you make charcoal, and kind of the way it's going to go from the whole wood charcoal or why you would use coal, is that you're going to do to the charcoal very much what you did to the iron ore. You're going to go to your mound, and this would be covered in dirt. That looks like some kind of wire mesh. That's not the way it works. You're going to take a bunch of wood, and you're going to put it in a mound, and you're going to cover it with dirt. And it's going to have a hole on the top and side, very similar to your bloomery, roughly speaking. And you want to do incomplete combustion. You want to burn some of your wood to produce lots of heat. And that high heat is going to do pyrolysis, or pyrolysis, probably a better pronunciation. And what's going to happen is whenever you have solid fuel, this actually happens in your campfire, etc. But it's going to start degrading the bonds of the wood, and it's going to start forming small molecules. And then those can turn into gases, and those will burn. Things like carbon monoxide for wood fuel, that's a major, what am I low on? Ooh, iron, that's not good. For wood fuel, that can be a major problem if you don't control your carbon monoxide. So you're going to pyrolyze it. You're going to get a lot of small gases. Those are what's going to burn. But because you're controlling the amount of oxygen in there, the temperature in here, well, I mean, it's hot, don't get me wrong, but it's not going to be anywhere near as hot as you would have in a fire. Or, kind of your traditional fire. So, you'll be pyrolyzing it, you're going to be driving off parts, but it turns out the oxygen and hydrogen are much easier to drive off from your wood source than the actual carbon. The carbon will quite often start forming these aromatic rings, that those bonds are very stable and don't break. So you're going to be converting your wood in there. Some of it's going to be going up as CO2. That's, of course, being produced to get the heat. But also, you're going to start producing a lot of graphite and graphene in there. And this is getting your charcoal, which is this lots of aromatic carbons that hold together very nice and tightly. Now, once the fire goes out, you break it apart, you pick that out. You can then burn that charcoal or coal. And coal has basically undergone this process naturally by being buried for a very long time. And this will now burn hotter, and in the case of charcoal, because it's basically relatively pure carbon, it's going to burn much cleaner. You don't get as much soot and ash. Therefore, it's better to be around. It still gives you smoke. Don't get me wrong. You still get soot and ash, but it's nowhere near as much as wood would get, especially wet wood, which can't get a high temperature and you get large gunk out of it. Now, by the way, if you want to purify your coal, you can take the coal and you can treat it like you would the wood and charcoal, and you can roast that coal, and that process is making coke, which is a purified carbon source, and we use that today in a lot of industrial use where we need, say, smelting or other high temperatures, or if we need pure carbon. That's usually how we get it. We take coal and we turn it into charcoal coal, which is what we call coke. Now, when it comes to this charcoal, obviously in the Middle Ages you'd be using wood. Now, this game basically treats all wood as logs. At this point in history, obviously you'd have big logs, but that would be used for construction. The small stuff, twigs, branches, stuff you couldn't use for construction, that would be used for fuel. But you don't have to use wood. Modern charcoal, if you go out and buy a charcoal briquette, that actually started out life as sawdust. That's a waste reclamation. You're getting sawdust that you were just going to throw away. Now you're turning it into a usable product, charcoal. Alternatively, you can use corn cobs, and this is being promoted in certain areas that have less developed areas, where people are doing subsistence farming, particularly with corn, obviously corn cobs, and so they got corn cobs left over. And by making charcorn, pun on the name, they're able to have a fuel source that doesn't require wood or other fuel sources that's basically free to them, and thus they're able to sell, so it gives them more profit. And because charcoal burns cleaner, less soot, less smoke, if you're sitting around a charcoal fire all day, it's going to cause less health issues from clogging up your lungs than if you're sitting around a wood fire all day. And it turns out for children under 5 in developing areas, lung issues, specifically due to wood smoke inhalation, is a major cause of death. And so the idea of making charcoal would definitely be a very valuable thing to do. So yeah, charcoal, really an interesting one. The whole concept of pyrolysis is really a fascinating area where you're getting this high heat, you're breaking chemical bonds, but you're forming a somewhat different, more stable carbon compound with those aromatic rings, and as such, you can do other things with it, including burn it and make a nice hot, clean flame. So yeah, interesting mod. Love the mod. It's definitely a powerful one, because if this guy is sitting here producing a lot of coal, it's definitely a pain. And so any vanilla players will notice that coal is always one of your nightmares. And all of a sudden it's like, blacksmith, it's out of coal. It can't produce enough steel tools, and then you run out of tools and you're up a creek. And so, great mod. Love the mod, and I love the historical implication and the tie-in that this mod does. So with that said, I'm going to go address this boat, and I will talk to you later. Ooh, cabbage seeds. I want some cabbage seeds.